and welcome everyone. Welcome to another live stream through the reactors. Before we get into the session, again, please take a moment to read our code of conduct. We're all here to learn, so please be respectful of each other's views, understanding of differences, and please be kind and considerate in the way you engage. Our chat will be open throughout, and we do encourage you all to participate. So please do ask your questions. Today we're back again with the second episode of GoL Clinics for Data. If you don't know what GoL is, it's called Game of Learners. This is the second episode. If you wanted to check out the first episode, you can go to this YouTube playlist, which I'm going to actually put in the chats in a bit. But without further ado, let me actually bring up Paul and Josh, who are leading this series. And I will let them take over.
All right. Thanks a ton, Rav. We're happy to be here today as part of the second session for the Game of Learners Clinics for Data. So we're happy to be here with our live stream event as part of Learn Live in partnership with the Microsoft Reactors. And today's session for Game of Learners Clinics for Data, session 2, is going to be on deploying and configuring servers and databases for Azure SQL. So if you are following along with today's content and want to join along on Microsoft Learn and complete the module with us together today, you can head to aka.ms/Azure SQL deploy configure, and that will bring you to the Learn content that we will be covering today. My name is Paul DiCarlo. I'm a principal cloud advocate on the data advocacy team at Microsoft. I'm joined by my colleague, Josh Indemenge. Josh, if you'd like to say hello to all the viewers out there.
Hello.
And Josh is going to be helping with any of the questions that come up through chat, moderating, surfacing your questions, which you can ask live and have those answered at the end of our presentation. And also, if you have any questions that are ongoing in that chat, being able to provide you with links or any sort of explanations that you might need for some topics that we may cover in today's presentation. So thank you for that, Josh. That's going to be awesome. So definitely, if you have anything come up, don't be afraid to ask in the chat. I do want to mention that this is the second for a full series of 10 sessions that we are delivering during the month of November for the Game of Learners Clinics for Data. And if you are interested in signing up for more of these sessions, you can head to aka.ms/GOL Data Clinic. That will give you links to register for all of our sessions, which include and cover a variety of different topics. So today will be our conclusion on our focus on Azure SQL. Next week, we'll be looking at real-time analytics, followed by Azure Storage Services, Azure Cosmos DB, and Azure Synapse Analytics at the very end. So do feel free to join along with all of this, because if you are a part of all of these sessions, that's going to help you achieve an opportunity that we're presenting as part of the Game of Learners Data Clinic, which is if you're interested in taking what you've learned here and wish to apply that to receive a Microsoft Azure Data Fundamentals certification, we're offering 200 free vouchers to take that exam. This normally costs approximately $100 USD. If you're interested in taking advantage of this opportunity, you can head to aka.ms/dataclinics/register, where there will be a form and information about an associated Cloud Skills Challenge, which is a collection of content on MS Learn. If you're one of the first 200 people to fill out that form and also complete all of the content in that Cloud Skills Challenge, you will be eligible for that AZ900 exam voucher. And on top of that, you can join other Game of Learners on the path to certification by asking questions at any time in our ongoing forum at aka.ms/dataclinics/forum. And that is a place where individuals like myself, Josh, as well as other members of the Cloud Advocacy Data team will be scanning for your questions as those come up through the month in helping you to achieve your goals of certification with the DP900 Microsoft Azure Data Fundamentals exam. So with that said, we're now ready to jump into our content for the day. And I do want to mention that at any point, you're welcome to ask questions in the chat. This is a live and interactive session. So number one, definitely, while Josh is here scanning the chat, would love for y'all to say hello. Let us know where you're from. I know it's morning in some areas, afternoon in others, possibly very late in the evening in other areas. And no matter what, we're happy that you're here learning live with us today. So without further ado, we're going to jump into our session for the day, the Learn Live Deploy and Configure Servers, Instances, and Databases for Azure SQL. So I'll be the primary presenter for today's content, and we're going to go ahead and get started with that right away. So let's go ahead, and we're now ready. If you want to follow along, again, I would mention that you head over to aka.ms/Azure SQL Deploy Configure. That is the URL that will bring you to today's Learn module that we'll be covering in completion. So if you head over to that link, you will find the Learn module in question, which we'll be bringing up just shortly. A few things to mention here. There are a few small prerequisites. Number one, any experience working with, maintaining, and developing with SQL Server, which if you joined us for our previous session, you definitely know everything there is to know about what you need to know for today. And also, it helps to have any experience with Azure, for example, deploying and managing resources. But if you don't, today's a great day to learn that. And we're actually going to allow you to do that with a free access to an Azure subscription using our sandbox environment, which requires no cost, nothing, just internet access, and you'll be able to spin up and create actual database services in the cloud as part of today's content. For this session, the learning objectives, what you will leave with today is an understanding on planning for deployment of Azure SQL, how to deploy and verify an Azure SQL instance using common tools and interfaces, how to configure SQL after a successful deployment, and finally, how to load data into Azure SQL using services in the cloud. So we're going to go ahead and get started. Again, if you have visited that link that we showed on the screen earlier, that was aka.ms/Azure SQL Deploy Configure, that will bring you to the URL that you see here, and you're now ready to jump in and start learning live with us on this session. So we're going to scroll down here and jump right into the introduction. And really quick, just want to cover what we're going to be talking about today. We're going to learn basically that process of deploying and configuring Azure SQL. And we're going to do this through hands-on exercises that operate with Azure SQL database specifically. And we're going to cover some comparisons between something we call the Azure SQL Managed Instance and sort of how that relates to regular SQL Server and or Azure SQL Database. Again, we'll be covering the previously mentioned learning objectives. In addition to the prerequisites that I mentioned, we're going to ask that you do install some tooling in order to follow along. So you can take a moment right now to begin reading through this and installing those prerequisites, and I'll talk about them shortly, hopefully while you're getting those underway. Number one, it's not a bad idea if you have a Windows machine to go ahead and try installing SQL Server Management Studio or SSMS. If you're not running Windows, that's totally fine. It's only using a very, very small part of this exercise, and I don't think you're going to miss out on much. But you can head to that download page for SQL Server Management Studio and find the latest stable release, this 18.12.1. And that will install that tool onto your system, which looks sort of like the following. Similarly, we are also asking that you install the latest version of Azure Data Studio. This is a cross-platform tool that can run on Windows, Mac, or Linux. So whatever your operating system is of choice, we do have an installer available for you. So we're not leaving anyone out. Anything that you're running should be capable of running this software, which we're going to be utilizing today. And finally, we're going to ask that you download a zip file of the course content or the lab materials that we'll be covering today. You can either click that link directly to download that, or you can head on over to the linked GitHub repository where you'll see where this is developed and maintained. You can clone it from there as well. If for whatever reason you would like to make changes to it or anything like that, that is totally an option. So hopefully you have all of that ready to go, because now we're ready to jump into the actual content for today. So let's go ahead and get started with our next unit, Plan, Deploy, and Verify Azure SQL. So before you start deploying things in Azure, it's important to understand what your requirements are and how they map to what is offered in Azure SQL. So in the previous Azure SQL modules that we talked about, we learned a few basic concepts, and it's now time for us to take what we've learned there to make a plan. So some of the questions you could ask: how am I going to deploy my database? Am I going to use the Azure Portal, which will give me a graphical user interface, or something more programmatic like a command line interface? Are we going to deploy to a virtual machine, database, elastic pool, managed instance, or an instance pool? What is our purchasing model? And for Azure SQL Database, there is the option of DTU, or Data Throughput Unit, or vCore, which is processor-based pricing. The server tier or service tier, which could be general purpose, business critical, or hyperscale, and hardware, which could be Gen 5 or something newer. And of course, your sizing, that number of virtual cores, and data max size, which would be what is that maximum size that we expect our database to be. And before answering these questions, you'll also need to pick a workload that's either going to be migrated from somewhere on-premise or born in the cloud. And it's important to note that if you are migrating, there's a number of tools and resources that can help plan, assess, migrate, and optimize your databases and application. And we're going to provide links to those at the end of this module. So because we're using the cloud, I mentioned that there's going to be things that can apply based service level offering that we choose when we deploy. And these can include things like input output operations per second, or in-memory OLTP for online transaction processing. And these resource limits are affected by whether you're choosing a managed instance, Azure SQL Database standalone. It can include things like the available memory, the maximum log size, the transaction log, the, again, data input output operations per second, the size of the temp DB, max concurrent workers, and backup retention. And the limits for Azure SQL Managed Instance and SQL Database are going to depend on what you've chosen for your service tier, your purchasing model, and how many vCores you have, or DTUs if you're using data throughput units. In either instance of Azure SQL Managed or SQL Database, these are going to be platform as a service offerings, which still allow you to enforce almost 100% compatibility with an on-prem installation of Azure, but with that benefit that now it's in the cloud, so you can benefit from things like or deploy to serverless or basic instances, depending on what your needs are. So as we go through the process, you're going to see we're going to cover a series of steps. And when we go through this, there's really 6 different stages. And to cover these from a high level, we're actually going to go through these, but we'll go through the basics, which will include things like what's our that we're going to use, what is the name we plan to use for our server, the name we plan to use for our database, the administration, login, and password for access, the region or geographic area to deploy to, and storage options, size we have for our maximum data in our database, and also the processing we would use. For networking, this is where we can set up things like public private access, firewall rules, and connection types. And for security, you'll see an option to turn on a single switch to activate Microsoft Defender feature, which will allow you for threat detection and also just give you a more secure way of deploying your instance with the ability to manage whenever threats are active on your database. So we'll also cover identity, as well as the ability to enforce transparent data encryption when connected to service. And finally, for our additional settings, here's where you can choose the data source that will populate your database, the server collation, which we'll talk about in just a moment, time zone, and geo-replication options. Finally, tags, which are metadata that you can use to describe anything that you deploy into Azure, which can give you a bit of metadata about what you have, which can sort of help you with internal operations or organization. And finally, we'll review and create by looking at the terms and privacy options available for our service offerings. So I'm going to go over a few of these, just skip over these sections for the purposes of time. Definitely would suggest looking back over some of this for more details. And we're going to go ahead and pick this up real quick on the concept of collations. So it is important to note that when you are creating a new SQL database or managed instance, to take into account the locale requirements of the data you're working with. And think about this like in various different languages, there could be different character sets. For example, not necessarily using the alphabet that we see in some. You figure either at a server level or database level what the default option is for the collation of your data. Now, by default, SQL Managed Instance as well as Azure SQL Database will enforce by default the SQL _ Latin 1 _ general _ CP1 _ CI _ AS collation. That's a lot to say. And if we break that down, what that essentially means is it's a SQL-based collation that utilizes a alphabet or language of Latin, general. CP1 references something called a code page that the collation will reference. The CI means that it's case insensitive. If you had CS, that would mean case sensitive. And AS means accent insensitive, whereas AI means accent insensitive. Accent, you think of the characters that you might see on top of letters in the alphabet, that sort of thing. And this all determines how characters are rendered by your application, how it can show them. And it can also have other available options, for example, support for different character widths or UTF-8 encodings. This is important because you'll see by default, this collation is going to appear in the databases that we deploy today. And it's important to note that for Azure SQL databases, while you can't change it at the server level, you can change it at the database level. So you're never necessarily stuck with a collation. You can always choose what that default might be, either at a higher level when using a managed instance or at the database level when using other service offerings. We mentioned Defender for Cloud. I just wanted to repeat on this. This is a one-click enable for a service that can allow you to identify and mitigate potential database vulnerabilities and enforce threat detection on your service. And one final thing too is when you do make your selections to create your deployment, Microsoft Azure will give you an option to automate your set selections. So if you wanted to deploy a database with the same configurations, that is totally possible. And if you're wanting to learn more about that, there's a number of modules available on Microsoft Learn related to something called ARM templates, ARM templates, which stands for Azure Resource Manager. We're going to gloss over a few of these other details that are mentioned here. Would definitely recommend that you go back and fill in on these concepts, but just for purposes of time and getting to what's most important, we're going to cover resource governance. So what this means is that when you increase or decrease, like say the amount of memory or CPUs available in a service tier, these can affect things that would change up to a certain threshold. And how Azure SQL accomplishes this is using a number of different dynamic management objects that we're going to look at today. These will tell you things like the job objects that are used by Azure SQL Server to look at things like files, virtual memory commit, working set caps, CPU affinity, and rate caps. And there is inside of Azure SQL a resource governor that can look at activity that's happening on your service and can scale it up or down as needed. And this is going to work in conjunction with a number of different features that are both part of Azure as well as part of SQL to make that happen. Once you've deployed an Azure SQL instance, it's likely that you will want to verify that. And again, looking at some of the dynamic management objects will allow you to understand different things about your deployment. And it's interesting to note here that if you were working with, say, a local instance of SQL Server, some of these features may not be available. For example, if you're looking at database resource governance, if you're on a local machine, there's no Azure backing it. So it doesn't have a concept of resources or virtual CPUs that are attached to it. So you'll notice some of these queries that we see here are available only in Azure SQL Database and or SQL Managed Instance. And you'll notice too, an interesting one for OS process memory, this is not supported in Azure SQL Database. Well, why would that be? And the reason is that the level of the operating system is not necessarily exposed to you in Azure SQL because it's just giving you an interface to a scalable database instance. And you don't have to worry about things like managing the operating system. That is Azure's responsibility. And so for these reasons, you'll notice like some different dynamic management objects, for example, this one does not have an actual result or an accurate result if you were to query that. But you'll notice here any of the resource governance protocols, these objects are going to be things that are specific to cloud deployed instances of Azure SQL. So in conclusion, with this first section on planning, deploying, and verifying our SQL instance, we're going to go over a knowledge check real quick just to make sure folks are understanding some of these concepts. So which of the following options below would give you or would have limits depending on your selection for deployment option and service tier? Size of temp DB, max log size, or backup retention, or all of the above? I think for this one, we actually mentioned at the top of this instance, temp DB is definitely one of them, as well as log size. We may not have necessarily explicitly mentioned backup retention, but that makes sense. And I want to say if we know for sure that it's two, the answer has to be all of the above. And then for the next one, we have a question for verifying deployments. Some new queries are specific to Azure SQL Database and Azure SQL Managed Instance. Which of the following queries are available only for Azure SQL Platform as a service? This one should be relatively easy to note because we were just talking about this. When a SQL instance is deployed to the cloud, there's this concept of resources that are available and a governor that chooses whether to scale up or scale down based on activity within the database. And you can see here, we do have that option for the dynamic management, this DM_user database resource governance. So I believe these are the correct answers. We'll go ahead and select that. And for the exact reasoning here, although worded a bit differently, you will see that these were correct. So hopefully this is what everybody else is thinking, and we're following along just well for this section. We're now ready to start getting into the exciting part. We're going to deploy an Azure SQL database. And to do this, we're going to leverage a sandbox instance of Azure. What's cool about Microsoft Learn is you don't even need an Azure subscription. Just click Activate Sandbox while you are logged in, and that will begin the process of standing up a time-limited environment that will allow us to create real Azure resources just as if we were working in a paid subscription. So this will take just a moment to complete. And when it does, that's going to give us the ability to start creating real resources that we're going to leverage in today's exercise. So you'll notice Sandbox is activated, and we've got 4 hours to play with our fresh environments. This is going to be a lot of fun. So let's go ahead and continue with these steps. We'll start with the signing into the Azure Portal. I'm going to go ahead and click to open this in a new window. And you'll see we're going to be presented with our sandbox instance. And I'm going to go ahead and put this side by side so that we can sort of follow along with these steps, and you'll be able to see where this is going in my Azure view pane that I have over here on the right. So the first thing it says is to type Azure SQL up here in the search pane. So we get a number of different results. We get service results, some resources, and then you'll see down here under Marketplace, this option for Azure SQL. We'll go ahead and click that, and you'll know that you're on the right track because you should see something that looks like the following screen. So it's going to ask us how we plan to use the service. You may remember from previous modules, we can deploy as a single database, single instance, or deploy onto a virtual machine. So I'm going to go ahead and select the single database option as it mentions here in the instructions. And we'll follow through filling out the steps in the deployment. So we're going to go through that 6-step process that we just talked about in the previous section. So we'll go ahead and choose our concierge subscription. And for my resource group, it's going to give us a default learn-random string of characters. Make sure that we select that. Then we'll scroll down here for the database name, and we're going to type AdventureWorks. This is going to be a sample database that we'll be working with. You'll note this does not have to be unique across Azure because this is going to be part of a database running in our server. So our server, we're actually going to need to create new. And in this instance, this will need to be a unique name. So what I'm going to go ahead and do, I've got an idea for what I want to name mine, just from having worked with this previously. I'm going to call this Learn Live /GOL Data Clinic. You'll want to use a different name for yours. I'm going to go ahead and choose that name and come down here to where it says authentication. Again, you'll want to choose a name that's fitting for your purposes. The name doesn't really matter, but recommend using something descriptive. And we're going to go ahead and use SQL authentication. Give it an admin name of Cloud Admin, as mentioned in the instructions here. And then we're going to give that a password that meets the requirements necessary. There we go. And as long as those match, it looks like we're good to go. And select OK to continue. That's going to give us the ability to create the server that our database will live in. We're going to skip over using an elastic pool, but it is important to note that an elastic pool can provide compute and storage resources that are shared between all the databases that it contains. And what's nice is databases within a pool will only use the resources that they need when they need them within configurable limits. So this is a nice way to get a scalability across your database and have that exist in a pool of resources rather than, say, a singularly contained instance. But since we're using no elastic pool, we're going to be on a single logical instance of Azure SQL Server. For the compute storage, we're going to leave this at its default, which is the standard series Gen 5 V2 or 2 V cores, with 32 gigabytes of storage. And we're going to leave the geo-redundant backup storage options selected by default. So we're now ready to move to our networking step, which we'll go ahead and click over to. And from here, we're going to start by selecting public endpoint. And we're going to allow Azure services and resources to access this server, and also add the current client IP address so that we can access this database from our home or laptop connection, whatever you happen to be using. But also this allowing Azure services is going to allow for things like if we wanted to use Data Factory to migrate data into our database, that's going to allow that connection to occur within Azure. It'll basically automatically open up the firewall for services hosted in Azure. And for the connection policy, we're going to set this to default. This is really interesting, and we'll talk about this a bit more in detail. But this will use a redirect policy for all client connections inside of Azure and proxy for those outside of Azure. Pay attention because we will revisit this concept in more detail shortly. Next, we can click on security. We can enable Microsoft Defender for SQL. There's no cost here, as our sandbox environment will self-destruct in 4 hours. So this will allow us to use those features if you wanted to explore those a little bit after today's session. It'll be turned on and ready for you. There's no harm in leaving that enabled unless you're in a paid subscription, then that would start to charge you after the 30-day free trial. But since this is a sandbox, you do not need to worry about that. Next, we'll move over to additional settings. And this is extremely important. Make sure in this section that for data source, where it says use existing data, we're going to choose sample. And we'll choose OK to continue. And it's really important to note here that we see the database collation. This is locked particularly because we just chose the sample data that's using the SQL Latin 1 general CP1 CIAS collation. But it's important to note, too, that if we did change this, it's possible to change this at the database level if you wanted to use a different character set. For example, you want to show foreign characters, perhaps in another language set that's not Latin-based. You can totally do that here. And we're now ready to move on to review and create. We get an estimated cost. Now, we are using quite a heavy load here for this sample database, but that's the beauty of the sandbox. We can play with real tools, real expensive stuff, and not have it cost us anything, which is just fantastic for a learning perspective. After we've done this, we can click Create, and this will redirect us to a pane that will show us the deployment of our database as it's being created in Microsoft Azure. So this will take a few minutes to complete. And so for that reason, we're going to go talk about some other stuff while we sort of wait for our database to come online. So this will take about 3 to 5 minutes, just depending on certain things. And hopefully everybody's able to successfully follow through these steps and has their deployment in progress. So how do we actually connect to our database once it's deployed? Well, there's a few things to look at here. I want to explain just visually, and some of this might ring or turn on some ideas in folks' heads if you have previous experience with SQL. So number one, let's imagine that we were connecting to a local instance of SQL Server 2019 that's like not in the cloud. To connect to that instance, we would open up a tool, something like SQL Server Management Studio, select the server type, give it the server name, and connect to that using whatever authentication mechanism makes sense. And once we did that, we'd probably see something like the following folder structure, the most important of which to pay attention to here is the system databases section would have a master, model, MSDB, and tempDB under that section. Now, if we're going to connect to our just now deployed database, we would take the name that we gave our database, provide that as the prefix, and then add .database.windows.net if it happens to be hosted in Azure. So you'll see that suffix that's added here denotes it is cloud hosted. And so now that we have that, we can then begin to make a connection to that database. Now, our bases are probably still deploying, as you can sort of see over here on this side. So what would it look like if we connected to that database? Well, it would look like the following. You'd get the database structure that we see here. You'll notice there's a lot less folders. And most importantly is under the system databases section, we only see a master table. Now, why this is because Azure SQL database, what you're truly interacting with here is something we would call a logical server. You're not interacting with the actual instance that it's running in. However, that is totally possible if you use a managed instance. And in a managed instance, if we were to connect to that, you'll notice this gives us a bit more structure that would be similar to that local installation. So you'll see here our system databases folder now has the master, model, MSDB, as well as tempDB inside of it. So in this exercise, we've seen how to deploy our Azure SQL database and how that kind of compares to a local SQL Server instance or a SQL managed instance. So now we're going to continue this comparison a little bit more, and we're going to verify our deployment that we have just created. So I'm going to go ahead and select Next. We're going to move on to the next unit, Verify Azure SQL Database. Now, in this case, what we're going to do is work with a different tool. So everyone should be able to follow along here. We're going to open the Azure Data Studio, and we're going to use that to create our connection. So you'll see here, just adding the status of my database that is being deployed right now. It looks like the server is coming online. You'll see this step here where it says SQL Server. That's a good indication that we might be able to connect to our database. You probably want to wait for that to be a check mark, but I found that you can connect a little early, and it may or may not have that AdventureWorks database migrated to it just yet. That's going to be another step in our deployment. So just make sure that as you continue, if any of these are still in progress, it's possible that when you connect, you may just need to wait a little bit longer. So how do we connect with Azure Data Studio? Well, if you haven't opened this tool yet, this is an awesome open source tool, cross-platform, should present you with a screen that looks like the following. We're going to go ahead and click up here on the upper left for connections. So give folks a few moments to open your Azure Data Studio, and we can now create that new connection. Now, I just know because of what I named my database, I should be able to connect to it using that naming feature that we had just talked about. So you'll see my server is online. I got a good feeling this is going to work. Like we can probably move forward here. So I'm going to select new connection. will give us the server of learnlive-gol-dataclinic.database.windows.net. If you don't know this URL, it's important to note that when the deployment has completed successfully, which ours is still underway, you can find this in the overview pane for your Azure resource, and I will show that in just a moment. We'll choose SQL login, and we'll use the credentials that we created during deployment, so that username and password, which should have been cloud admin and a password of your choosing. Then we can select this drop down for database, and it should give me some results. This is great. It's giving me the AdventureWorks database. If you're not seeing this yet, you're going to definitely want to wait until it populates with that AdventureWorks database, but I've got it, so I'm ready to proceed, and hopefully you will be as well in just a few moments. So make sure you've selected AdventureWorks. Remembering the password will save you a few steps, of course, and now we're ready to connect. And so what's great here is now that we've connected to our instance, we can start to issue queries against our server. So you'll see now that we've got a bit of details about this, we can see where it's running on a Gen 5 _2 tier, see information about various different things like the build number, build version, error log, etc. I'm going to just really quickly click here on new query, because what I love about Azure Data Studio is once you've connected to a data source, you're basically working with that. It almost sets like a context. So we can run queries like something like select version, give me the version of a SQL instance. Go ahead and copy that and paste that over here. And you'll see there's the result that I got for querying version. And we'll talk a little bit more about that in just a moment. So before we move on, as I mentioned, once your deployment has completed completely, which it looks like ours has, I'll go ahead and click on Go to Resource. And if you don't know that URL for your database, you can find that right here. So where it says server name, you'll see again, it's that Learn Live GOL Data Clinic, which was what I named my database, with the suffix .database.windows.net. So this is how you would find that if you didn't otherwise know how. So the steps that you should see here in the Learn module are going to follow what we just showed, how to actually connect to a database instance. Again, make sure you select the AdventureWorks database. And now you have a live connection where we can start issuing queries to our connected instance. Our final thing that we're going to do is set up easy file access. So if you recall earlier, we downloaded that zip file from the GitHub repository that contains the lab materials for today. So if you downloaded that zip, you'll want to extract that, and then you'll want to find that path, because we're going to locate that within Azure Data Studio. So what I'm going to do here is head into my Azure Data Studio instance. And from here, I'm going to select File, Open Folder, and navigate to that directory. So mine was in Downloads. Here's the extracted folder. And you're going to want to select the O2 Deploying Configure folder, where you should see a Load Data and Verify Deployment folders, pairing of folders there, and select folder when you see that option there. Now this is really cool because it sees that inside that folder are Jupyter-based notebooks. If you don't know what those are interactive notebooks that can allow us to issue queries against a connected data source. So in our case, just following along with the Learn module is going to ask us, after we've done that, to go ahead and select one of two ways of proceeding. So option one is that you can open up SQL Server Management Studio, connect here, and continually issue queries, which I feel is a bit of a slow way. There's a lot of copy pasting and going back and forth. So I'm going to recommend that you scroll all the way down in this module to where it says option 2, which I think should be option 1. This is the preferred way, superior in all ways, where we're going to open the verified deployment Python notebook. So you'll see there is one for MI, which I believe stands for Managed Instance. SS, which I believe is for standalone SQL Server, and there's one that just says verify deployment. So we're going to go ahead and click that one. And once that opens up, we can follow the instructions inside. So this is going to tell us that we should confirm that the kernel is set to SQL, which it is. That means that the language of the notebook is issuing SQL queries. And then we're going to change our connection and attach to this existing recent connection we have to our AdventureWorks database. So you should see AdventureWorks here and select connect. And what's awesome is now when we scroll through this document or notebook, we can select these previously written queries and select the play button here on the left. And that's actually going to issue that query to our cloud hosted database right from the Azure Data Studio tool, which is awesome. So you'll see here in our first query, we got this result, which is interesting to note because we're querying something that's in the cloud. And I'm just popping over to this screen so I can show you the full contents of that result. It's not a versioned result that we get back. We're actually getting this number, which corresponds to the fact that Azure SQL is versionless, and the number is not necessarily comparable to what you'd get from a SQL server. Like it's not like a V18 or something like that. And that is because Azure SQL includes the most up-to-date changes, and that happens behind the scenes in the cloud. So when the Azure SQL team makes an update and you deploy an Azure SQL database, you're always getting the latest and greatest underneath the hood. This is a great way to tell, if you don't know where your database lives and that sort of thing. These are good tools and techniques to know to identify perhaps where that server is running. In the next cell, we're going to issue a query that's going to ask and return the type of SQL deployment. So we're going to look at the server property engine edition, and this gives us a result of 5. Which corresponds in this table to SQL database, which isn't super surprising. But you'll notice there's other options there, and depending on the version of SQL that you're running would give you a different result. Now we're going to look at some of the system level objects. For example, the views for sys.databases and sys.objects. These views are going to give us a collection of all databases, which isn't surprising. We have our master and our AdventureWorks databases or tables that we saw earlier, and databases. I don't want to say table. These are full standalone databases on their own, and system.objects view, which will tell us about various different system level parameters that are available to our SQL instance. You'll notice this looks very similar to if you were querying a local SQL Server instance. As this is going to have things like system tables, internal tables, and user objects that are used by our sample database. Now let's look at some of the things that you're really only going to see here because of how we deployed our instance. So remember, we used a 2 vCore selection for our deployment. So we can select from the dynamic management view OS schedulers where status equals visible and online. You'll notice I get 2 results back. These are schedulers, which corresponds to the CPUs underneath the hood that are working to run our database. And you'll see the scheduler addresses, the CPU ID. You'll notice there's 2 results because we have selected 2 vCores. And we're now finally going to look at the resource governance. Remember, this lives in the cloud, so it has these parameters that are part of that database instance that know how it can and should scale by looking at things like the service level optimizations that it has, the limits for CPU. So in this case, has a limit of 2, but could have a max or support a max of 64 CPUs. Requires a minimum cores of 2, etc. And you can see how these parameters actually help Azure underneath the hood. In an instance where you would want to do auto scaling and that sort of thing, the resource governor can look at this type of information and make decisions based on that. And finally, we're going to look at the dynamic management exec request view to see currently running SQL requests. And you can see there's a number of requests that are currently active. This will actually return any requests related to your database, including background tasks as long as they don't have a context that shows up as master. And this is because of how the Azure SQL database deployment, where each database is deployed in its own SQL Server instance and how that works. So we've now completed all of the concepts that are covered in this interactive notebook. We will be returning here to go through another one later on in our presentation. So hopefully everybody's following along. We've now completed option 2 for using the SQL notebooks in Azure Data Studio to verify our deployment. We're now ready to move on to the next section. So I'm going to skip over some of these concepts just in the purposes of time. It is important to understand some differences between SQL managed instances and Azure SQL. The most important that I really want to look at here is that in a managed instance, you do necessarily get that default server collation of the SQL Latin 1, et cetera, that we've been looking at. In addition to the following options that are set to on, the one I want to point out here is something called full recovery. So if you wanted to restore a database, it can support through its service level optimizations and service level requirements full recovery, which means that taking in the full restore when performing a recovery of your database versus something like a limited or like a quick restore or something like that that's using a heuristic. It does support full recovery, which means your data is always intact. This is going to be important for one of our questions below. Also, it's important to note here concepts around storage management. So for Azure SQL database, the maximum size of your database files depends on your chosen SLO or service level options. And you can choose a data max size up to this possible maximum size. Now, it's important to note what is the difference between these. So there's a concept of max size and data max size. Now, data max size is how large your data could potentially grow, whereas max size is how large your data has actually grown. So you could have a max size of 500 gigabytes, but a data max size of 1 terabyte, which would mean you still have 500 gigabytes of data left to grow to if you needed. And it's interesting too that this is backed by a concept known as the transaction log, which is truncated regularly. And this size is always 30% of the data max size. So for example, if you had a data max size of 1 terabyte, then the maximum transaction log would be 0.3 terabytes. A transaction log stores all transactions, updates, removals that have happened in your data. It can allow you to unwind, and again, services that ability to perform things like recoveries. There's differences in different tiers, specifically in the data Azure SQL hyperscale tier. This uses a completely different mechanism that's described here. And importantly, now I want to talk about the connectivity architecture and policies. So what's happening network-wise when we're making a connection to our SQL database? You may recall that in that networking step, we chose a default option that was proxy for connections from outside and redirect for connections within Azure. So how this works is if I'm, say, on my laptop and I want to connect to my SQL database, this will first need to proxy through a gateway, like an internet gateway that gets me to that Azure data center. And upon successfully making that connection to the gateway, can then find the connection into the database. However, if I'm using a redirect query, that could allow me to go directly to where I need to go. So if you had an Azure hosted, you had, like, say, an Azure hosted virtual machine running in Azure, that could technically redirect itself to directly connect to the database. Now, typically, this is a two-step process where the first thing it does is it will go through the gateway in order to find the database. Once it retrieves that internal IP, it will just speak to it through there instead of going through a gateway. The key to understanding here is that redirects are going to be faster, lower latency than a proxied connection. And that is because there's less network hops in order to make that. So in this mode, the connection is generally established using that first step and then that second step to perform the redirect. So if we're going through a knowledge check here and we're looking at a data max size of 10 gigabytes, what's the maximum transaction log size? In our case, remember that's 30%, so that should be 3 gigabytes. It's approximately 30% of 10 gigabytes. And what's the default connection policy for Azure SQL Database and Azure SQL Managed Instance? As we just mentioned, connections outside of Azure would be proxied and redirected for connections within Azure. So hopefully this makes sense to everyone. If we check those answers, those are correct. So we're now ready to proceed and move on to the next exercise where we'll discuss configuring the Azure SQL database. Now, this exercise is interesting because it's going to allow us to change the access policy and sort of look at any effects that that might have. I'm not going to go through this one completely for the purposes of time, but what this is going to essentially demonstrate, if you do go through this, it's going to allow us to programmatically change that connection policy from proxy to redirect. And you should notice that when we force redirect on our connection policy, that is going to create significantly or remarkably improved performance because of reduced time to make a query to our database. So what this would look like, I'm going to go through this one a little fast. I do apologize. Over here in the right-hand side, we have our Azure Cloud Shell. This is going to give us an Azure CLI or command line interface that will allow us to issue commands programmatically from a command line to interact with our Azure resources. So once that's populated, we'll come down here, or we're going to issue the first set of PowerShell instructions. So go ahead and paste those in. Now what these are doing is it's essentially attempting to find the resource group name within our Azure Sandbox, as well as the database name within our Azure Sandbox. So I could do something like, if we wanted to print this value for the database name that we just received, we could do that, and you'll see it got the name AdventureWorks. So without giving you a full primer on PowerShell, just hopefully that's an understanding of what's happening here. So now that we've set those variables, we can configure our resource group and the logical server contained within using the Azure configure command. And we'll then run the AZ configure list defaults. This will show us those defaults that have been configured here. You'll see here they are, the .azure/config for our resource group, and here's one for our database, the Learn Live GoL Data Clinic database. If I want, we can issue something like Azure AZ SQL DB list, which will give me all of the Azure SQL databases, which is a lot of information. So let's go ahead and limit that. Go ahead and actually, clear this. And we're going to run a lighter command here that's like Azure SQL database show -- name, database name, which should be AdventureWorks. And you'll see this gives me the information on that database. You can see it's running on a Gen 5 2V core machine. That can be inferred from some of the results coming back here. You can see that it's a general purpose edition, lives in the West US, etc. This can be really important. Like using this tool, there's a lot of cool things you can do for scripting, automation, deployment, and that sort of thing. And then we'll determine the size and usage. So I'll go ahead and clear this again and run list usages on that database. And you'll see here, we can see the allocated size of our database. And I believe this is being reported in megabytes. That would make sense, or sorry, in bytes, as it mentions down here. It is mentioned in bytes. So you've seen how these commands work. I'm just going to show you that you can do this. If you wanted to view the connection policy, so remember by default, we're doing that proxy from outside, redirect internal. You can see that we have a connection type of default set. If we wanted to change this, you can do that here and change this to type proxy for all connections. And if you were to continue with this, there's some instructions that show you how to monitor queries once you've changed that connection type and see if they're going faster or slower when you change the different types. In this example, it indicates that using the proxy mode, you'll get like a 46 millisecond, I want to say, response time. And whereas if I update that to instead use redirect, we'd get 25.8. So a significant reduction there, almost 50%. But it depends on a lot of factors, like how close you are to a data center, etc. This final command here is actually going to set that policy back to default. That's where things were when we started. I'm going to go ahead and set that back just so we can proceed. So hopefully that made sense. You can see how with the CLI tool, we can do things like query our server, also do things like manage the connection policy, change that, etc. So for our final exercise, we're going to load data into Azure SQL, and there's a lot of ways to do that. You can use bulk copy program or BCP, bulk insert operations like you would normally use on a database, using SQL Server integration service packages, which is generally done a little bit more in on-premise deployments, and various other options. In fact, we'll link to some of those in the end of the presentation. But this should make sense here. Finally, we're going to just go through a quick knowledge check, and I've actually gone through this. I don't think this was very clearly specified in this content, even though we're skipping over it. It's going to ask, in which Azure SQL deployment options support natively restoring a database, meaning can allow you to do like a full restore. Well, we know that an Azure VM can do everything SQL can do. And it might not be clear, it's actually not mentioned in this module, but Azure SQL Managed Instance can also do this using a URL. And finally, the second question, which is not an example of how you can more efficiently load data into Azure SQL Database and Azure SQL Managed Instance, using simple recovery mode is not available. As you saw previously, full recovery mode is required by the SLA. So let's go ahead and check those answers. And for the reasons mentioned, these are the reasons why these would be the correct answers. So now for our final exercise, we're going to load in data into our SQL database. And we're again going to do something similar to before. There's two ways to do this. You can use SQL command in the Azure Cloud Shell, or what I think is the more fun way, so that would be option one. We can go down to option two and use Azure Data Studio, which I absolutely love this tool, so I'm going to recommend option two for completing this. Now, to do that, we can simply click on the Load Data notebook that should be available. That was part of that GitHub repository of lab content. And similarly to what we did before, we're going to set the kernel to SQL and attach to our existing connection. And it looks like, go ahead and copy that connection string. I just recall mine is learn live GOL data clinic.databases.windows.net. Oh, actually, we don't need to do this. You can see right here in the recents that it mentions, it already has my AdventureWorks. Yeah, let's do that. Let's use the recent connection. Then I have to go back and find everything. Awesome. It's cool. So that made this really easy. Now, when we run any of these cells, they'll be activated against our AdventureWorks database. So let's go ahead and in step one, we're going to create this table and schema. So this is going to create a schema for store returns. So this AdventureWorks sales data, there is no store returns data by default. So we're going to go ahead and create a new table that contains things like return date, return time, the item, the customer, etc. Now, this concept may not be very clear, so I'm going to explain it and just know that this needs to be done. And this is better explained in our documentation, but we're going to create a master key. And the reason why is we're going to pull data from an Azure storage blob that has an SAS container or SAS key, shared access key that's required in order to connect to that. And this will require that we create what's called a database scoped credential. And in order to do that, we need to create the master key. Because I ran that twice, you'll notice I got an error here. That's totally fine. As long as you're getting a mention that there is a master key in the database, you are ready to proceed. For the scoped credential, you'll see here, we're creating this scope credential against a publicly accessible, well, I shouldn't say publicly, it needs that shared access key. So it's not anonymous access, but a public storage blob in Azure. We're creating this with identity shared access signature and using the SAS token in order to create that scope credential. That's going to allow me to securely essentially create access to that storage container and download the contents of the blob. In the next step, we're going to create an external data source data set of type blob storage located at that URL, Azure SQL Workshop/data, and we're going to use the credential that we just created. And now that we've created that, we can actually insert that data into our newly created table that has the schema we defined in the first step. So if we run this statement, this is going to take a while. It's actually going to import something on the order of like 2 million rows of data. So at this point, I would say now is a great time for us to let this continue while we sort of close out our session. And we'll refer back to this just for the purposes of time. So in a summary, as you saw, we were able to do quite a bit of pretty awesome stuff today. We learned how to deploy and configure Azure SQL, different queries to tell things about the instance that we're running, how to verify our deployment, then going forth further into looking at things like the connection policy, how to change that programmatically with Azure CLI tools, and finally loading data from an Azure blob storage into our database instance using scoped credentials. If you are interested in these topics, you want to learn more about this, highly recommend there's a link inside the summary section for a video series related to this learning path. This is excellent stuff. It's got Bob Ward, who's done 26 plus years of development on Azure SQL. So this is like literally learning from, or should I say SQL itself, because it didn't exist that long ago. But this is someone who's seen the evolution of SQL from its birth to where it is in the cloud today. You'll also be able to see more information on deployment planning, verification, etc. And some of those concepts like data max size, like if you want to learn more about that, there's links to those resources. And any of the sections, and even going further, like if you would like to load data using things like Azure Data Factory into something like an Azure SQL Managed Instance or Azure SQL, it shows you exactly how to do that. So this is really awesome resources. Definitely want to recommend those. And also say that if you are familiar with data concepts and you want to achieve a certification, or maybe you're interested in this and you just want to start learning, would definitely suggest checking out aka.ms/Azure SQL Data Fundamentals Cert. This link will bring you to the Azure Data Fundamentals certification. And finally, would like to mention one more time that DP900 Azure Data Fundamentals exam. If you have stayed through our Game of Learners session, we'd like to tell you that if you're one of the first 200 to click on the link mentioned here, aka.ms/dataclinic/register, and complete the Cloud Skills Challenge contained within, you'll be eligible to receive a voucher to take the DP900 Microsoft Azure Data Fundamentals exam at no cost, 100% free. And we're also offering the ability to learn with others. If you choose to go that path, it might take a month or so to complete that content, maybe less. We've seen some people complete it in a few days. But if you have any questions along the way, join other Game of Learners who are on that path to certification by heading to aka.ms/dataclinics/forum. So with that said, we're almost at time here. We'll go ahead and bring Josh back up on the screen, who's been helping in the chat there. Hey, Josh. How are things going in the chat?
We have no questions yet, but as we've mentioned, anyone who has any question, you can just go on to Tech Community and you can just leave it, your question there, and someone will respond, maybe from our side or anyone from the community might as well be able to respond to any questions you might have.
Excellent. Yeah, so if anybody has questions about this session or any of the upcoming sessions, feel free to ask those questions in the aka.ms/dataclinics forum. Just one more thing. We're almost done here. Looks like our command completed successfully. So we're going to run that final command to select the counts, so the amount of items that were just inserted into that table. And you'll see from blob storage, we just imported 2,807,797 rows. That is a lot of data. So cool stuff that we've covered today. It's been a real pleasure presenting with all of you. Happy that we've had folks tune in from all over the world. And we look forward to catching you at the next Game of Learners sessions starting again next Tuesday. So join us for Ismail, who will be presenting on real-time analytics. Can't wait to see you there. Cheers, everyone.
Thank you.